Ow, that claw is right on my cuticle. Cats are like exes. They know exactly how to hurt you the most with minimal effort. Hello Internet, my name is Quinn, and this is Blondihacks. Got a bunch of odds and ends to do on the locomotive this week, and then we're going to make some additional pieces of the valve gear. So let's go. I decided that it's time to catch up a bit on my powder coating. I've got a set of components now with the cylinders and some of the bracketry that is solid. It's not going to change. It's not going to need further modification, at least not substantially, so it's safe to powder coat. I'm trying to powder coat things as I go along so that I don't have some giant, overwhelming task at the end, but you also don't want to do it too soon because you might need to do further modifying of parts if things don't fit right and so on. I'm not going to go into detail here. You've seen me powder coat lots in this series. Watch this playlist from the beginning if you want a lot more detail on the setup that I'm using here and all of the processes involved. I can say that I'm, I guess, a year, maybe 2 years in now on this home powder coating setup, and I'm still really happy with it. Produces great results. I am getting better at it. It's pretty easy to get good results. Getting really amazing results has taken some practice. And one of the main things I've learned is that the inspection phase before you bake it is very, very important. If you have any thin spots in the powder, the brass will show through, and if you don't fix it now before you bake it, it's very difficult to fix it later. Next, I decided I think I can safely seal some things up. I think I can reasonably safely say, I don't even like saying this out loud because I don't want to jinx it, but I think I can say these cylinders shouldn't need to come off again. If they do, it's not the end of the world, but I would like to try sealing things up and once again not be left with a giant sealing job at the end. So for these precision fits, like the manifold to the cylinder face, these are being done with Loctite 518. This is the recommended sealant in the drawings. This stuff is used, for example, in split case transmissions, in machinery and motorcycles, things like that, where you need a little bit of a seal between machined surfaces, but you don't want to mess up the tolerance of the fit of them. You don't want to add a bunch of thickness to that interface. Same with the steam chest to port face interface. I don't want a thick gasket here because it would push the valve rod up in a way that's undesirable. And these things should never really need to come apart again. So again, Loctite 518 is a good choice here. This stuff is very, very sticky and cures quite quickly. I actually had to redo one of the cylinders because I didn't get it bolted on quickly enough and the sealant cured at a funny angle. So I had to pry it apart and remove it with acetone and start over. It's really, really good stuff though, I gotta say. Hopefully I got all of that sealed. We'll know for sure when I start putting air in things. On the top of the steam chest though, here I do want a gasket because as I install the valve here, you can see that the valve is very adjustable and it will need regular adjustment at the beginning as I get the locomotive dialed in, and there's likely to be maintenance required in here. So over to my new friend, the vinyl cutter, and I'm going to cut some gaskets from this Felpro paper gasket material. I think it was a viewer who actually suggested when I introduced this vinyl cutter that it can be used for cutting gaskets, and that's a heck of a good idea. So I gave that a shot. And I gotta say, it works incredibly well. It took me about 10 tries to get all the settings right the first time I did it. All of these newfangled digital tools are like that. You gotta get all the settings figured out for each new material or each new type of task that you do with them. That takes a lot of trial and error. Typically, you scrap a bunch of material, but then you keep a notebook, and next time you do something similar with the same materials, you know all the settings. So in my case, this is 25 thousandths paper gasket material. If you happen to have a silhouette vinyl cutter, this is blade depth 10, force 25, and 6 passes, and that seemed to work super nicely. You may not have considered one of these vinyl cutters for your shop. Well, turns out they in fact do almost everything that a laser cutter does for 1/10 of the price. So keep them in mind. Run this by the quality control manager really quickly, and that is deemed sufficient. Dimensionally, these gaskets actually all came out perfect the first try. Really the only trial and error was with getting the cut depth and the cutting force correct on the machine. But scale-wise, they came out perfect. I didn't have to scale something up 2% or whatever, which again, sometimes with these digital tools, you do have to do that. I also made gaskets for the front cylinder heads because the front cylinder heads do need to come on and off pretty regularly, at least in the beginning, for adjusting the piston rod length. There's a screwdriver slot you might remember in the end of the piston that's used to twist the piston in and out of the crosshead as needed. Whereas the rear cylinder heads are sealed in place with the Loctite 518 because they essentially should never need to come off, and the tolerance of that fit is really important because the crosshead rails mount to the rear cylinder head. That sound you hear is a bunch of commenters furiously typing that how dare I cover up that brass because brass was so beautiful and they liked the way it looked with just the brass. Well, tell you what, when you spend years of your life building this locomotive, you can make it look however you like. Yes, brass is nice, we all like brass, not a revelatory opinion there, but I'm trying to make this look a little more prototypical. I want this to look more like a model of a locomotive and not a clockwork toy of a locomotive. On now to the next piece of valve gear, which is the union link. This connects the crosshead to the combination lever. If you watched my video on Walschaerts valve gear, then you know what this connection is for. It's the connection shown in light green here. And what this does is allows the piston to exert influence over the valve timing, which, Bueller, maintains constant lead. I knew you knew the answer. That is the magic of Walschaerts valve gear. These little links are going to be made from this 1/16 thick 1018 steel. Because I need 2 of them and they're very thin, I'm going to glue my blanks together and I'm going to machine both of these components at the same time. So I clean the surfaces thoroughly, clamp that glue up for at least 15 minutes, make sure it's strong enough to withstand all the machining that we're about to do. And now I'm going to start over here on the rotary table. These links have a dog bone shape, and I think what I'm going to try to do is I'm going to drill a hole at one end. I'm doing this on the rotary table because the sides of these pieces are not parallel, so I can't clamp them in the vise because they're just pieces of scrap glued together. So I drilled a hole in one end, and I'm going to clamp it to the rotary table, and now I can drill the actual holes for the parts the correct distance apart with the DRO. If you watched me make the combination levers, you know I struggled with sufficient clamping on the parts on the rotary table. So that's why I'm taking this approach now with extra stock on the part that's being clamped and screwed in place. I thought I could make these parts entirely on the rotary table, which is why I didn't machine the sides and drill the holes in the vise, but it turns out I need a reference edge, so I went back to the vise anyway, aligned those holes with some pins for reference, and machined a surface that'll be parallel to those holes. I need this reference surface because to lay out the dog bone shape, I need to do that on the surface plate, which then requires a reference surface parallel to those holes. I've been experimenting with techniques for dog boning these tiny parts, and I think what's working best for me is to lay out the end points of the dog bone feature on the surface plate, and then you'll see how I'm going to align these layout marks on the rotary table. Another way I've done this is to draw up the part in CAD and calculate the starting and ending angles on the rotary table. That's really time consuming though, because it requires aligning the part on one axis with the rotary table, which takes a lot of time, and on a really small part like this isn't very accurate anyway. With the reference hole then aligned on the center of the spindle, I now bring in a pin that's the same diameter as the cutter I'm going to use, and I rotate this around until the edge of that pin just touches my layout line. I've also tried doing this with the actual cutter, but that's not accurate enough because depending on how the cutter happens to be rotated, the 2 or 4 flutes aren't going to be in a good position for lining up with the line, and it's kind of hard to tell where the corner of a flute is, whereas with the gauge pin, the same diameter as the spinning cutter, it's very, very clear. Then I finally come in with the cutter and cut to the angles on each side that I noted on the rotary table with the pin. So this method I find is really working well because it's much, much faster than the CAD method. It doesn't require the part to be aligned to any particular angle on the rotary table, but it's still much more accurate than eyeballing it with the actual cutter. So this is really kind of a sweet spot on accuracy versus convenience, I find. Particularly with regard to the orientation of the part on the rotary table not mattering, because all you're doing is cranking around until the pin lines up with your layout, and whatever angle that happens to be on the rotary table, you go back and forth between that angle on one side and the other angle that you find on the other side, and you're going to end up with a nice looking dog bone, and you didn't have to do any alignment. That alignment of the part on the rotary table is very time consuming, and as I said, on really short parts like this, it's frankly kind of impossible to do that accurately anyway because you just don't have enough material to reference for putting a dial indicator on. And again, these dog bone details are aesthetic. They don't have any function, so they just have to look nice to the eye. And I find this pin method really does a nice job of making a nice looking dog bone. And again, the actual dimension that you end up with doesn't really matter. That has worked out very nicely. The extra stock to hold onto the part was a big improvement over how I tried to do the combination levers, so this is definitely an improvement. Then the other end I did the same way. Again, just milling my way full cutter width all the way through this oversized piece of stock. That's working just fine. I'm just plunging down a little bit at a time and working my way back and forth. And there we go. I've got the dog bones done at both ends, and now I can mill the straight section in between. Again, this is an improvement over how I've previously done parts like this, where I would try to create the dog bone feature at the end when the part is tiny and difficult to hang on to, and it just makes everything so much more difficult. So do the tricky feature first, which is the dog bone end, and then go and do the easy stuff afterwards, which is the straight cuts in between. For depth, I'm just milling down a little bit at a time until I can feel that the straight surface has connected with the low spot on that rotary table cut, so that we get a nice tangent transition between the curve and the straight. And again, doing that by feel is sufficient. The dimension on the center of this part is not very critical, it just needs to look nice. As with all of these valve parts, they're overbuilt by 10,000% or something, so strength is never a concern. We're just trying to make things look nice. That's gone quite well. The dog bone shape is a little bit lopsided here and there, so I thought I'll correct that with a little bit of filing. And then I remembered that filing by hand is for chumps, and I have a die filer. So I did a little fine tuning over on the die filer. One thing about rotary table setups is that there's a lot of sources of error in them. The rotary table has to be perfectly aligned to the spindle, the fixture plate has to be perfectly aligned to the table, the part has to be perfectly aligned to the fixture plate, the table, and the spindle. Each of those sources of error is very small, but on a very small part like this, if you've got even a couple of thousands here or there of error in that rotation of the table relative to the reference center hole, then you can see the lopsidedness, you can see that off-centeredness of the round outside compared to the center hole. If you're off by 5 thousandths on a part that's an inch across, you can't see that. But on a part that's 100 thousandths across, you can absolutely see a 5 thou of error. It's one of the challenges of making these really tiny parts. After some filing though, I'm much happier with that shape. So now I can put it into the acetone, which will simultaneously remove the layout die and also separate the two parts. You can do this with heat as well, but heat will discolor the parts and doesn't actually help you with the die cam. You got to put that in acetone anyway. So these days I just soak it in acetone and do both jobs at once. If they're very well glued together, you might have to soak it for a couple of minutes, but the acetone will wick its way in between the parts and dissolve that superglue. There's the completed union links. I'm pretty chuffed with how those came out. You know, again, they're a little bit lumpy in the wrong places, kind of like me, but that's okay. They are going to do the job just fine. And again, considering how small these are, you're never going to see them this close up in real life, so I think they will do the job just fine. Now, I took some of the lessons I learned from those parts, and I'm going to make the next set of parts, which are even smaller. These are the union link brackets that go on the crosshead. So here you can see I've machined the sides of the two pieces glued together first, and then I'm drilling the hole pattern in the vise. Now I've got nice reference sides all the way around with my hole pattern, so now it's easy to do the layout on the surface plate. See, I'm learning. These parts have a little dog bone feature at the bottoms of them. So once again, I'm laying out the skinny part of that feature on the surface plate, and then using a very similar setup on the rotary table to carve out that dog bone feature. For these parts, I experimented with changing the way I set the spindle on the center of the rotary table. I've traditionally done that with a pin that fits into the center of my rotary table and just do it by feel. This time I centered the spindle on the table before setting up the part with a dial test indicator. I kind of suspected that was probably my largest source of error in my rotary table setups, and I think this experiment proves that out. The concentricity of the resulting feature for these parts is quite a bit better than it was on the union links. I may continue to do that in the future, even though it's quite a bit more work to set it up that way. I think the result is noticeably nicer. That came out great. Yep, we do things right on Blondihacks because we do them twice. I scrapped the parts on the first attempt at that dog boning because look at what I did. I went back and forth between the two correct angles on the rotary table, but I went the wrong way, and I sliced right through the middle of my part. I went back and forth, blissfully milling away, not realizing what I was doing to the part. Let me tell you, when I wound that table back and saw what I'd done, I just about cried. But there's no crying in machine shop, so I hitched up my pants and made the parts again, and really that only cost me about an hour. To cut the remainder of the outside of shape, I did this with layout. Again, the outsides of these parts are aesthetic. As long as the holes are all in the right place, it will function correctly. So the goal is just to make it look nice. I did this with a combination of surface plate work to create the center lines of the holes and the tangent points of all the rounded corners that are going to be here. And then I connected the dots for those angles with hand layout. Now to cut those angles, I'm going to use a simple technique that I use a lot. I put a parallel on top of the vice jaw, and I line up the scribe line on the layout by eye. Especially with magnification, this is actually really very accurate. And then when you move the parallel, now you've got room to cut, and you just cut down to your layout line. When a feature is strictly aesthetic like this works super well, and it's very, very fast to set up. Again, cutting down until I feel it connect with the inside of the dog bone feature by feel. Then I know that my tangent of the curve and my straight edge are meeting up nicely. If it feels good, it'll look good. Then I cut the top of the part down to my layout line using pins in the holes for parallel reference to keep this straight. Again, nothing dimensionally critical here as long as the holes are all in the right place, so just trying to make it look nice. I need to round those two top corners now. I could do this on the rotary table, but as I've just explained at length, this is tricky, time-consuming to set up, and the end result won't be nice if you don't do it absolutely perfectly. I've also got my belt rounding, belt sander corner rounding fixture. That's hard to say, but that's not good for this part because of the dog bone at the end. I can't get all the way around on the belt sander without damaging the end of the part. So I'm going to go old school. I'm going to make some little filing buttons. I've done a whole video on filing buttons if you want to know how they work, but also just stay tuned because you're about to see how they work. Got a piece of tool steel drill rod. This is 01 tool steel. I'm going to face off the end as is tradition. And then I'm going to put a center in it for tail support because I want to pull it out quite a ways. And I'm going to turn down the OD of this to the radius or twice the radius of the outside curve that I want to create on the part. A lot of times the radius on a part is just a standard dimension, like 1/4 or 3/8 or something. And that's awesome because you probably already have drill rod hanging around that's that diameter, and you don't have to do any lathe work at all, or minimal. But in this case, it's a bit of a strange dimension because the part is so small, so I grabbed the closest side I had and turned it down. And I'm going to put a little emery on that because we do need a nice finish because we're going to be heat treating this. I'll do a quick dimension check as well. Not that this is really a critical dimension, but it's a good excuse to keep an eye on your lathe, making sure your tailstock is staying in alignment, that sort of thing. Never hurts to check your work even when it's not important. I cut that long piece in half now, and I need to hold these two pieces, but now they're a weird dimension, and I don't have a collet the right size to hold it in the collet chuck for a second operation. So instead, I'm going to grab this scrap of aluminum, I'm going to face off the end of this, as is tradition, and I'm going to make a quick and dirty emergency collet. This is a technique you've seen me use before, but I'll show it again because it's incredibly useful and super fast and super effective. And I don't see a lot of people on YouTube doing it. I'm not claiming to have invented this. I don't know where I learned this one, but it's an obvious technique, let's just say that. But it's a good one to know if you've never seen it. So you drill and ream a hole that's the exact diameter of your part in the scrap aluminum, and then you go over to the bandsaw and you cut a slot most of the way through the part. Clean that up, deburr it nicely so it won't interfere with the collet, and stuff it down into the collet chuck. And there you go. Now we have a custom collet chuck, the exact diameter of our part, and that will clamp down with the outer collet. And the concentricity and the repeatability of this is actually really excellent. You can pull parts in and out, you can change parts, you can flip parts around. It's going to hold your concentricity super well. It's shockingly accurate and really takes seconds to make. So keep this one in your back pocket if you ever need to hold on to a weird part and you need to do multiple operations without losing concentricity. In my case, I need to turn a little shoulder on the ends of both of these two pins, and they're going to reference the center holes of the radius on the part, as you'll see. A little aluminum temporary collet like this is so fast to make, but they actually are reasonably durable. Like, you can use this probably a dozen times before you're going to wear it out, or before the aluminum fatigues at the flexure joint. So I keep these in a drawer, and you never know, someday in the future I might have a very similar piece of stock that I need to hang on to. Once again, as I said, this repeats and holds concentricity super well, so swap in the other one and cut the same little shoulder on it. Thanks, little aluminum adapter collet. You are the hero we need but don't deserve. There's the 2 filing buttons, or filing sticks, I guess, and I'm going to go and heat treat these now. If you're only going to use them once or twice, heat treating is pretty optional. They're tool steel, they'll hold up just fine for a couple of uses, but on the other hand, heat treating them literally takes 30 seconds, and then you can put them in a drawer and use them for life. Once again, you might need to do a similar operation in the future. Things in the built world tend to typically be a small range of standard dimensions, so the odds are actually pretty good that you'll need to do the same operation sometime in the future. With filing buttons, I don't bother tempering them. There's really no need. They don't see any appreciable forces, so the brittleness of just being fully hardened is fine. For filing buttons this small, I find the easiest way to make them is to just put a little shoulder on them and then clamp the pair of them across the part in a vise or a clamp or something like this. These are really too small for any kind of threaded attachment. For really large filing buttons, usually you can put a hole through the center of them and put a bolt through them. For smaller ones, sometimes you can make the filing buttons so they thread into each other in the center of the part. But for these really tiny ones, this simple shoulder and clamp method seems to work the best for me. And now the fun part. You just file until you can't file no more. The file buttons are harder than the file, so you'll know when you're done because the file will just start skating over the part and it'll stop cutting. To finish the last little part of the corner, I can get in with a needle file and get in around that dog bone feature at the bottom, which was the problem with the belt sander method. Very nice. Filing buttons are honestly very quick to make and super fun to use. I should make them and use them a lot more than I do. I've made all these fancy fixtures for doing this job, but good old filing buttons, it's a 100-year-old idea that still works awesome today. Look at what a nice job that does. It's so nice and really easy. With both corners done that way, it's once again into the acetone to remove the layout die and separate the parts. Then a little bit of deburring and needle filing, clean up the edges, that kind of thing, and these parts will be done. Making these really tiny parts is kind of a skill set all its own, and I'm slowly getting better at it. I'm learning new techniques, different setups, and so on to make these tiny parts look as good as possible. I know the clock and watchmakers out there are laughing at how giant these parts are, but for me, this stuff is small. I'm still getting the hang of it. Let's get these bolted onto the locomotive and see how they look. I'm going to use these little brass screws temporarily. I don't have steel screws in this size, but I would like these to be steel. I'll also mock up the rest of the connections with some temporary pins. I've got a whole bunch of specialty clips and pins to make that hold all of the valve gear together, but for now, you can get a sense of how it works with these temporary pins anyway. And there she chooches. Looking pretty good. Of course, that's not the actual combination lever motion, because without the radius rod in place, there's no pivot for the combination lever to be swinging on, so the valve isn't moving, and the whole thing's just kind of lazily flopping back and forth. So this is not the real combination lever motion that will be created by the Union Link when we have more of the pieces done, but you get the sense of it anyway. Things are moving, things are starting to chooch in the valve gear, and that's pretty cool, and well, I'm pretty pleased with how these parts are going so far. I hope you enjoyed watching me make these little guys. Lots more to come on this valve gear. Thank you so much for watching. Thanks to my patrons for making this content happen, and I will see you next time.